Welcome back to this part 2 video on reflection and mirrors. In this specific video, we will be covering curved mirrors. This would include concave and convex mirrors. See our previous video on plane mirrors and more information on basic reflection. Now before we move on more deeply into reflection, we really need to consider some basics. So as you can see here, we have a concave mirror. First, we need to talk about the principal axis. The principal axis is an axis that goes through the center of the curvature and extends outwards. The second thing is the focal point. The focal point is really important as it appears in many of our reflection problems, which we will cover at the end of this video. The third one is the center of curvature. The center of curvature is an important point to know because it is the center of the spherical mirror. Now, one important relationship we need to make here is that the center of curvature is twice the distance of the focal point. Now, let's move into the most important topic in this unit, which is finding the image of an object from curved mirrors. As you can see here, we have a concave mirror and an object that's represented by a green arrow. So there are two types of strategies in order to figure out the image of an object from curved mirrors. The first one is a parallel ray. So the parallel ray starts off parallel to the principal axis and then when it comes in contact with the curved mirror, it would go through the focal point. So I'm going to represent how it looks like. So as you can see here, the parallel ray started off parallel to the parallel axis, and once it came in contact with the mirror, it went through the focal point. Now the second strategy is known as the focal point ray. This ray does the opposite though. First it goes through the focal point and then goes parallel to the principal axis. So as you can see, it first went through the focal point and then went parallel to the principal axis after making contact with the mirror. Now, the final step is finding the image. Well, this is pretty simple. To figure out the image, you just have to figure out where the two rays intersect. As you can see, this is where the two rays intersect. Therefore, in order to figure out the image, we just make an arrow going towards the point. So as you can see, we have just found a real image of the object. Now let's look into a variety of examples involving our methods we just used to figure out images from curved mirrors. Now let's first look at this example, where the object is outside the center of curvature. So now let's draw parallel rays. Now let's draw our focal point rays. Now as you can see here, the intersection happens between the focal point and the center of curvature. So let's draw our image. Now, key things we need to take from here. First of all, the image is between the focal point and the curvature, and it is also much smaller compared to the object. The image also is a real image. The image also is inverted compared to the original object. Now let's move on to the second example. Over here, the object is exactly at the center of curvature. Now let's draw our parallel and focal rays. Now as you can see here, the image is exactly at the center of curvature. However, it is inverted. So key things to take away from this example is that the image is the same distance as the object from the mirror. However, it is inverted and it is the same size. Now let's move on to the third example. In the third example, the object is between the focal point and the center of curvature. Now let's draw our focal and parallel rays. Now in this example, the image appears to be outside of the center of curvature. So let's look at some key things we need to take away from this example. The image is much larger compared to the object. The image is a real image, and the real image is inverted. Over here in this example, we see that the object is exactly at the focal point. Now let's draw our parallel and focal rays. Now this looks completely different because it seems that the reflecting rays do not seem to intersect. They go parallel to each other. As we know, parallel rays would never intersect. This means that there is no image for this object. So key thing to take away from this example is that when an object is at the focal point, then we would not get an image. Now moving on to our final concave example, let's have the object be between the mirror and the focal point. So now after drawing our parallel and focal rays, we see that the intersection does not happen before the mirror. This is when we have to extend the rays backward behind the mirror and make our image. As you can see here, the image appears behind the mirror, therefore we consider it to be a virtual image. So now key things to take away from this example is that the image is a virtual image, the image is much larger than the previous object, but the image is however upright compared to the object. Now that's all we have for concave mirrors. Let's move on to the convex mirror. So as you can see here, let's have the object outside of the mirror. Now if we draw our P rays and F rays, it seems a little different here. So let's use our method from our previous problem and extend the rays backwards. So as you can see here, we have both our P rays and F rays. And it seems like the intersection point is well into the mirror. Now, after finding the intersection point and making our image, we have a few key concepts we need to take away from this example. The image is much smaller compared to the object. The image is also a virtual image compared to the object. However, the image is upright when we compare it to the object. Now, as you can see here, these are the 6 key examples that would appear on any physics test regarding curved mirrors. Thank you for seeing this video on reflection in mirrors.